All right, so this is going to sound a little crazy, kind of like something straight out of a sci-fi movie. But believe it or not, the very foundation of our digital world, yeah, the internet's address system, is basically running on empty.
So what's the magic number? It's this, 4.3 billion. That was the absolute maximum number of addresses we could have under the internet's original rulebook, the one called IPv4. And back when they came up with it, that seemed like a huge number, like way more than enough for everyone on the planet.
But fast forward to today, and well, we've got way over 10 billion devices connected. I mean, think about it. Your phone, your laptop, your smartwatch, maybe even your fridge. So wait a minute. If we have more devices than addresses, how is this even working? How are you watching this right now? Why hasn't the internet just fallen apart?
Well, to get to the bottom of that, we really have to wrap our heads around the scale of the problem. We're talking about the internet's address crisis.
And this is where you can really see the problem. On one hand, you've got those 4.3 billion IPv4 addresses. But on the other hand, we have more than 6.5 billion people and over 10 billion gadgets all wanting to get online. The numbers just don't work. It's simple math, right?
So, what's been holding it all together with duct tape and a prayer? It's this clever little trick called Network Address Translation, or NAT for short. Now think of it this way. It's like a big office building with only one public phone number. Inside, everybody's got their own extension, right? But to anyone calling from the outside, it's just that one number. That's exactly what your home Wi-Fi router does. It takes the one public IP address your internet provider gives you and shares it among your phone, your laptop, your TV, all of it.
But here's the thing, NAT was never meant to be the final answer. It was a Band-Aid. A clever one, for sure, but still a Band-Aid. It actually makes things more complicated behind the scenes. It can cause headaches for stuff that needs a direct line, like when you're gaming online or on a video call. It totally breaks the original, beautiful, simple design of the internet. So yeah, it was a patch, definitely not the cure.
Okay, so the world clearly needed a real solution, a permanent one. And that solution, the big, ultimate upgrade, is Internet Protocol version 6. You'll hear it called IPv6.
Just look at that number. Seriously, that is how many addresses are available with IPv6. I know, right? It looks like someone just fell asleep on the zero key. But I promise you, it's not a typo.
So how do you even say that? It's 340 trillion addresses. It's a number so big our brains can't really process it. I mean, get this. It's enough to give a unique address to every single atom on the face of the Earth. And you'd still have tons left over. It's insane.
So how on earth is that even possible? Well, the magic is all in the math. See, the old IPv4 used a 32-bit address. That's what gave us the 4.3 billion. But IPv6, it uses a 128-bit address. And when you jump from 32 to 128 bits, the number of possibilities doesn't just double or triple, it explodes exponentially. And that's how we get this basically endless supply of new addresses.
But wait, there's more. IPv6 isn't just about having a ridiculously huge number of addresses. No. It's a massive upgrade to the internet's entire plumbing system. And it comes with some seriously cool built-in superpowers.
Okay, so what are these superpowers? Well, for starters, its header, the bit of info that tells data where to go, is way simpler, so routers can handle things faster. It brings back that true end-to-end connection, which means we can finally say goodbye to NAT. It makes new devices plug and play. They can just connect and set themselves up automatically. Plus, security is baked right in from the start with something called IPsec. It even makes your data travel smarter by sending it to the closest server. I mean, it's a win-win-win across the board.
All right, so a whole new address system means a whole new format. And I'll be honest, when you first see an IPv6 address, it can look a little scary. All those letters and numbers. But don't worry, let's break it down. It's actually not so bad.
So you know how IPv4 had those 4 groups of numbers separated by dots? Well, IPv6 has 8 groups, and they use both numbers and letters. That's called hexadecimal, and they're separated by colons. Each of those little groups is just a piece of the much larger 128-bit address.
Now, thankfully, nobody wants to type that whole thing out. So there are a couple of cool shortcuts. First, you can get rid of any zeros at the beginning of a group. And here's the best part. If you have a big chunk of groups that are all zeros, you can just replace them with a double colon. You can only do it once, but it makes a super long, clunky address way shorter and easier to handle.
This little chart here really lays it all out, side by side. You can see the huge difference in address size, the way they're written, how devices get set up, and especially security. It's super clear that IPv6 isn't just a small tweak, it's a total evolution. It was designed from day one to be better, faster, and way more secure.
Okay, so we've nerded out a bit on the technical stuff, but what does any of this actually mean for you, like in your everyday life? Well, this is where this invisible upgrade gets really interesting, because it's literally powering our future.
The impact in the real world is massive. It means every single gadget, your watch, your car, your thermostat, can have its own unique public address. That's absolutely crucial for the whole Internet of Things to really take off. It's what makes true plug-and-play possible. You just buy a new device, turn it on, and it works. And at the end of the day, it's laying the foundation for a faster, safer, and just plain better internet for every single one of us.
So by solving this address crisis, we've basically unlocked the Internet's final boss level. We've removed one of the biggest roadblocks to its growth. This whole shift, it's not just some boring technical fix. It's like we've just discovered a whole new digital universe to explore. And that leaves us with a really exciting question to think about. Now that we have a near infinite digital world, what are we going to build next?